So this is the lesson for Appendix C. Let's start by looking at some equations. We have x squared plus y squared equals 1. And we know that since both terms are squared and both terms have the same denominator, it is going to be a circle. The general form or equation for a circle centered at the origin is x squared plus y squared equals r squared. This could also be written as x minus h squared plus y minus k squared equals r squared, where h and k locate the center of the circle. If we look at y equals x squared plus 1, we know that only the x term is squared, so this is going to be a parabola, and so this equation is a quadratic equation. This can be written as y minus k equals a times x minus h squared, again where h and k locate the vertex. A will show us how skinny or wide the parabola will be, and if a is negative, that means it will be upside down or opening down. If we have x squared over 9 plus y squared over 4 equals 1, these have different denominators and both terms are squared. So this means it's going to be an ellipse, which is basically a fancy name for an oval. So we can set y equal to 0 and we'll get x equals 3. And if we set x equal to 0, we get y equals 2. And then you can sketch in the little rest of the ellipse there. If we have x squared minus y squared equals 1, this subtraction in the middle will show that it is a hyperbola and both terms are squared. So a hyperbola kind of looks like an X, and it depends which term is first to see if it opens side to side or up and down. All of these shapes come from a double-naped right circular cone and slicing it different ways. Just a little note, so you know that all of these are related somehow. So let's look at a couple examples. First, find an equation of the circle with a radius 3 and centered at 2, negative 5. So we have radius equals 3, and we know that the center, h and k, are 2 and negative 5. So we can use the formula x minus h squared plus y minus k squared equals r squared, plug in our radius, h and k, and we get our answer of x minus 2 squared plus y plus 5 squared equals 3 squared. And that's enough because all it said was to find the equation. Example number 2 says to sketch the graph of the equation x squared plus y squared plus 2x minus 6y plus 7 equals 0. Let's rewrite this so we have x's and y's together, and we can rewrite it as x squared plus 2x plus y squared minus 6y equals negative 7. So we just moved the 7 to the other side. We are going to complete the square, and so we will have x squared plus 2x plus 1 and y squared minus 6y plus 9. We got the 1 by taking half of the coefficient of the x term, so half of 2, and then you square that. 1 times 1 is 1. And again, we got 9 by saying half of negative 6 is negative 3. Negative 3 times negative 3 is positive 9. And whatever you do on one side of the equation, we have to do to the other, so we added 1 and added 9. This can be rewritten as x plus 1 squared plus y minus 3 squared equals 3. And if we were to sketch this, we have our center at negative 1, 3, given by h and k in our little parentheses there. And the radius is going to be the square root of 3, which is 1.7362. So go ahead and sketch that. Now, example number 4, if we sketch the region bound by the parabola x equals y squared and the line y equals x minus 2, we know that this is a parabola which is open on its side. And we put in a little line there and mark the region in between the two. We can find a little bit more information about this. If we take our two equations, x equals y squared and y equals x minus 2, and substitute the second into the first, we will have x equals x minus 2 squared. If we FOIL that out, we'll have x equals x squared minus 4x plus 4. Subtract x on both sides to put all terms on the same side of the equation. And we get x squared minus 5x plus 4, which can be factored into x minus 1 times x minus 4. And for those to equal 0, x will equal 1 and x will equal 4. So we can put that information on the graph. And then if you want to find what those y coordinates are, you will put those numbers back into one of our equations. And if you put in 1 equals y squared, that will be 1 equals negative 1. We know it's negative because it's in the lower half below. It's a negative y coordinate. And if we put in 4 for x, y ends up being 2. Example number 5 says to sketch the graph of 9x squared plus 16y squared equals 144. Let's set this equal to 0, so we'll divide everything by 144. And after we reduce that, we get x squared over 16 plus y squared over 9 equals 1. So let's go ahead and start graphing this. We know that when we set y equal to 0, x is going to be 4, and when we set x equal to 0, y is going to be 3. So you can plot those on your x and y axis, sketch in your ellipse. Example number 6 says to sketch the curve 9x squared minus 4y squared equals 36. Again, let's set this equal to 1, so we're going to divide everything by 36. After you do that and reduce, you will get x squared over 4 minus y squared over 9 equals 1. We know that this is a hyperbola because of the subtraction in the middle. If you have x squared minus y squared, it will open side to side and look like an x. And if you have y squared minus x squared, that will open up and down, and that kind of looks like the Under Armour sign. So that's how you can know which way it will open. So let's go ahead and start graphing this. We know that if we set the terms equal to 0, the other ones will be 2 and 3. So mark 2 for x's and y for 3. We'll draw our boxes and our diagonal lines. Diagonal lines are going to be the asymptotes, and that's where our line is going to get really close to those but not actually reach that. And the vertices will be on those points of x equals 2 and negative 2. Moving on to example number 7, it says sketch the graph of the equation y equals 2x minus 4x plus 1. And we know because only the x is squared is going to be a parabola, and our equation for a parabola is y minus k equals a times x minus h squared, or y equals a times x minus h squared plus k. So that just depends if you want k to be with the y or on the x side. Let's use the first one, and we will have y minus 1 equals 2x squared minus 4x. We're going to complete the square, taking half of the x coefficient and squaring it. And then you will have y minus 1 equals 2 times x squared minus 2x plus 1. This means that we are going to add 2 to the y side because it's not just a 1 in there. We have it multiplied by 2 on the outside of the parentheses. So we get y plus 1 equals 2 times x minus 1 squared. Then we have h and k. And we know the vertex is going to be negative 1, 1 from h and k. So go ahead and plot that, and then you will sketch in the rest of your parabola. All right, our last example is number 8, and it says sketch the curve x equals 1 minus y squared. We know this is going to open to the left, and it is going to be shifted 1 unit to the right. So it's a parabola, only one of the terms is squared, and it opens to the left, shifted to the right, and that's all you have. All right, good luck with your homework for Appendix C.